Hey guys, welcome back to Dynamics video series. This video is going to be a continuation of our special points discussion, or just all the problems that we're doing that have to do with the special points method of analyzing these structures. This video is going to include relative terms, right? So in the last video we had a special points problem and we did the solution for it, but not all of the, all of them, all the equations we used didn't have the relative terms, which we'll get into in the problem. But essentially it's when two or more points have a changing distance between them. It's not fixed. So we'll see. Okay, so let's go ahead. So at present, the red slotted link is horizontal and d equals 2 meters, right? So this is 2. Or let's just put 2 up there. The red link is rotating at 4 radians per second clockwise and has an angular acceleration of 2 radians per second squared counterclockwise, right? So at present, this thing is going this way at 4, and that is the velocity. And then it is also going the other direction, the other direction at 2, and that is the acceleration. Cool. So the blue link is 3 meters, so this is 3. The angle is 30 degrees, so let's say this is 30. Block C is moving up at 3 meters per second. Okay. Sure. And it wants to find the time derivative of d. What is d dots, right? So it wants to find the first time derivative of d, or this variable up here, right? So I hope you can imagine it, right? That as this blue thing is spinning, right, or rotating, that the little point right here, or the connection point B, right, that connects this blue rod that's fixed to the blue rod and the B point to this red rod, or this red slot, is going to be sliding in and out of this actual, the slot, right? So it can either be going towards A or out of, into the slot, or it can be going away from A and then out of the slot. And our job is to figure out d dot, or just the relative velocity of A and B for this case, right? Because that d distance measures the distance between A and between B. Okay. So knowing that, let's go ahead and start with some equations. So let's write down kind of what we know first, right? With our directions. So we assume that going up is going to be the positive j, and going to the right will be the positive I. Right? Get used to doing the I and j and k vectors. Continuing on, so we know a couple things, and we know that the velocity of c, right, was given, and that's only going to be a plus 3j. We know it's only in the j because of the constraints that this thing has on its sides, right? So it's fixed, or it's in this weird little slot where it can only go up and down. It can't go left and right, so there's going to be no I component. So this is going to be fully in the j. So VC is 3j. We know that the angular velocity of that red stick was given as 4, right? Now, since it's 4 clockwise, and because we're using the I, J, and K components, we know that clockwise is actually the negative direction, and counterclockwise is the positive direction. So this is -4 in the K direction, right? We also know it gave us its angular acceleration, so again of this red thing, and it was 2 in the counterclockwise, so that's a plus 2 in K. All right, is that all we're given? Just about. So let's go ahead and start creating our special points equations. I'm just going to quickly write out the formula in case you forgot it. It goes like this, where you have a point on some body. Let's just call it point little a, right? Not to be confused with big A that we're using in this problem. And that's for another point on the same body. The velocities are equal when you take into account a couple things, and that is the what's called angular velocity of the entire body. And then that's with the cross product of the position vector between the two. That's a weird R. That looked like a V. The position vector from B to A, or from this point to this point, right? And also it's not big A, it's little a. And then plus any relative velocity terms they have. So if they're getting closer or farther away from each other, stuff like that. So let's use this equation, right, for our system. So I'm going to first do it for this red link, or this red bar. Right? So I have to pick a point to be on the left side, and for this problem, I'm probably going to pick point B. The case is if I do a equation for the red link and then an equation for the blue link, both links have point B, right? So I can just equate them at the end. It's getting my algebra a lot simpler if I start with B on the left side for both equations. So let's do that. So my velocity of B, that vector, is equivalent to, and then velocity of A is the point I'm talking about, the other point, plus the angular velocity of the body they share, which is the red link, with the cross product of the r, or the position vector from A to B, and then plus any relative velocity terms they may have. All right, so let's start filling in values. So VB equals VA. Now VA, or the velocity of point A, so point A is on a fixed support, right? It's on this little thing. So it's not going to have any velocity in the I or in the J, right? So that's just going to be a 0. Plus the angular velocity of the R, which was given as negative 4k, with the cross product of their position vector. So if we're going from A to B, as I indicated with the arrow, I'm going from this A to this B. I am traveling a total of 2 meters in the positive I direction, right? So that's just going to be a positive 2I. Okay, and then plus any relative velocity terms that you may have. Now, relative velocity is any velocity, so things are getting closer or farther away, and that's just going to be the same as my d dot, right? So that actually is what I'm looking for. So d dot. Let me do the cross product to simplify this a little bit. So the velocity of B equals, before I do that, so d dot, we'll notice that this bar is horizontal, right? So d dot, since D is running horizontally and there's no component in the J, this d dot component is also just going to be horizontal and only going to be in the I, right? There's nothing in the J so far, at least at this moment in time that we're looking at. Okay, so let's do the cross product here. So this is multiplying this coefficient times this coefficient, so negative 4 times 2, that's negative 8. And then k cross I, that is going to be a positive j, right? So this is going to be same sign and then j. Now we're going to add that to my d dot component. So d dot and the I. Okay. So that's my equation for my red link. Let's move this over just to save some space. Now for my blue link, I'm going to create the same equation where I'm going to keep the VB on the left side to make the algebra easy. But now I'm working with the point B and point C, right? Because that's the points I'm looking at for this blue bar. So VB equals VC, right? Plus the angular velocity of this blue bar with the cross product of their position vector from C to B, and then plus any relative velocity terms they may have, so VREL. Okay, so VB, same thing. VC was given, right? We figured out that it was plus 3j, so this is going to be a plus 3j. And then plus the angular velocity of the blue, which we do not know, so we'll leave it as a variable. But let's just assume it's in the positive k direction. It's helpful just to always assume it's in the positive k direction. If you don't, you assume it's in the negative k direction, then you're going to have a flip sign somewhere. I always just leave it as if I have an angular velocity or an angular acceleration unknown, I'm just positive k, right? Because I know if I get a negative value, it's the other way. Okay, and that's times the cross product from C to B. So let's look at this triangle we have going, right? So we do go up a vertical distance to get to B, and then we go left a horizontal distance to get to B, right? So since this angle is 30, the one on the side of it will be the cosine of 30, and then the one opposite of it will be the sine of 30. Cool. Okay, so my cosine of 30 is in the J, right? So let's do that. So this is going to be, the distance is 3. And then that's the cosine of 30, right? And that is the J component. So that's positive J. And then we're going left, right, to go in the I component to B, right? So that's going to actually be a negative I. So this is going to be minus 3 times the, 3 times the sine of 30. Okay, and that is my I component. And then is that it? Well, yes, for the position, but we still have this relative velocity term. If you can see that B and C are going to have are going to have 0 relative velocity compared to each other because they are like fixed in points on the same bar. At no point as this thing rotates are B and C going to get closer than 3 meters from each other or farther than 3 meters from each other. So that relative velocity term just becomes 0, right? So we can kind of just leave it out. So let's get rid of that. Okay, let's do this cross product to make more sense. So this equals 3j plus, and then I have my multiplication of my constants, so I'm going to multiply both of these terms. So that's 3wb cosine of 30, right? And then k cross j, that is a negative I, right? So we're going to have an I here, and then this sign is actually going to become, I erased a little too much there. This sign is going to become a negative. Okay? And then we have negative 3 sine of, oh, sorry, not negative 3, negative WB sine of 30. And then this is K cross I, which is positive J. So I'm going to put that there, and that's going to leave the signs the same. Okay. Okay, so now I have these two equations. So let's equate them, right? So I have two equations that sum up to VB, right? So I can just equate them to each other. And what that means is because these are vectors in the I and the J, it means that the I's and the J, well, the I's of one equation equal the I's of the other equation, and the J's of one equation equal the J's of the other equation. So I can actually just create two equations here for my I and my J components from both equations, right? So let's do the red components first, right? So in the I have just this di, or this d dot, so I have d dot, and this equals the I components from the blue equation, right? So this is my only I term, so this is a negative 3 WB times the cosine of 30. Okay. And then for my J components, for my red equation, I just have that negative 8 equals, and then for my blue J components, I have 3 minus 3 WB, and then the sine of 30. Okay, so now let's look. I have, let's see, 1, 2 equations with 1, 2 unknowns. So this is now fully solvable with algebra. Let's see what these values are. So you can pick whatever method you want, like always. You can do Mathematica, MATLAB, by hand, calculator. Just make sure whatever you do, you can do it on the exam and you're good at it. Save yourself time. When I do these, I get two values. I get that d dot is negative 19.05. So what does that mean? Now, since we established that right is positive, that means this thing is going left, right? And that is, I'm pretty sure in meters per second. Yeah, meters per second. And then we have WB, right? And I got that this value was about a positive 7.33, right? And since this is a positive, we're assuming this is the positive k direction, so that is counterclockwise, right? Okay, so these are going to be my two answers for this problem. I think it only wants the d dot, but you can get both when you do the algebra, or you need the WB to actually get the d dot. But that's going to be how you solve these. So make sure when you're solving these relative terms that you are giving the relative term to the right link, and you are properly summing things in the I and the J, and making sure your K values are all good. That's going to be about it. You guys can always let me know if you have questions. Bye.